Hello friends, in this video we will start the exercise 10.3, but before starting exercise 10.3 I will explain some basic terms. General equation of a line, different forms of ax plus by plus c is equals to 0, that is a slope intercept form, normal form, distance of a point from a line, and the distance between two parallel lines, and all the short examples before exercise 10.3. And in my second part, I will explain all the examples from the exercise 10.3. I will give the link of that video in the description box of this video. Now let us start. Now first, the general equation of a line. In earlier classes, we have studied general equation of first degree in two variables, ax plus by plus c is equals to 0, where a, b and c are real constants, such that a and b are not 0 simultaneously. Okay. Graph of equation ax plus by plus c is equals to 0 is always a straight line. Therefore, any equation of the form ax plus by plus c is equals to 0, where a and b are not 0 simultaneously, is called general linear equation or general equation of a line. That is, ax plus by plus c is equals to 0 gives us the equation of a line. Okay. Now the next, different forms of ax plus by plus c is equals to 0. The general equation of a line can be reduced into various forms of equation of a line by the following procedures. First, slope intercept form. It means that in that equation we will have the slope and as well as the intercept. If b is equals to not 0, then ax plus by plus c is equals to 0 can be written in this form. How we can write in this form? See this here, that is a by. Transfer this ax and c to the right hand side, and that terms will become minus here ax minus c. Divide on both sides by b, then here you will get minus a upon b into x minus c upon b. Okay, or this equation can be written as y is equals to mx plus c, and this is the equation number 1. But what is m here indicates? M means what? Minus b up minus a upon b. M minus a upon b, and what about the c? C is a minus c upon a. Okay, and therefore we can write y is equals to mx plus c, where this is the famous equation for the slope intercept form. And in this equation, m indicates the slope of a line and c indicates the intercept made by that line on y-axis. Okay. We know that equation 1 is the slope intercept form of the equation of a line whose slope is minus a upon b and y-intercept is a minus c upon b. If the b is equals to 0, then what you will get? You will get x is equals to minus c upon a, which is the vertical line and whose slope is not defined. If x is equals to minus c upon a, and that's we have learned in the first part, that is in first exercise, when x is equals to a, that line is a parallel to y-axis, and whenever the line is parallel to y-axis, its slope is not defined. But we have its x-intercept, it is a minus c upon a. Okay, now the intercept form. Now suppose here c is not equals to 0, then ax plus by plus c is equals to 0 can be written as. Then how this equation has written? The first see this here, ax plus by transfer this plus c to the right hand side. Okay, it is here, and it will become minus. I will write here minus sign. Okay, here is a minus c. Now divide the whole equation by minus c, and therefore you will get here ax upon minus c plus by upon minus c is equals to 1. Again, this equation can be written as x upon minus c upon a, okay, plus y upon minus c upon b is equals to 1. And therefore, the small a indicates minus c upon a and the small b indicates minus c upon b, and therefore the intercept form, and this is also nothing but the double intercept, x upon a plus y upon b is equals to 1. This is the intercept form. Okay, we know that the equation 2 is intercept form of the equation of a line whose x-intercept means what? X upon, which is that minus c upon a, and that is nothing but the x-intercept is a minus c upon a, and the y-intercept is a minus c upon b. Okay, whatever that divided by y. If c is equals to 0, and then ax plus by plus c is equals to 0 can be written as ax plus by is equals to 0, which is a line passing through the origin and therefore has no intercept on the coordinate axis. See this here, the x-axis here, and here is a y-axis. Okay, and this is the line which passes through the origin, and it has the form of y is equals to mx. C is not present there because this line passes through the origin. It does not make any intercept on the coordinate axis. It passes through the origin. Okay. Now the next normal form. Let x cos of omega plus y sin of omega is equals to p be the normal form of the line represented by the equation ax plus by plus c is equals to 0. Transfer this c to the right hand side, then it will become minus. Then ax plus by is equals to minus c. Thus both the equations are the same, and therefore as these two equations are same, equivalent, therefore see this equation and this equation. Therefore divide the ax upon x cos omega, then x will get cancelled and you will get a upon cos of omega. Divide this by y sin omega, then yy will get cancelled and you will get this b upon sin of omega, and finally divide this minus c by p, and here you will get minus c upon p. And from this equality, we will find out the value of cos of omega and sin of omega. Now see this here, a upon cos of omega is equals to minus c upon p, and therefore cos omega is equals to minus ap. This p will multiply to a and c will be divided to ap. Therefore cos of omega is equals to minus ap upon c. Again equate this, b upon sin of omega minus c upon p. Therefore sin of omega is equals to minus bp upon c. This is the sin of omega. Now add these two square and add these two terms, that is a sin square omega plus cos square omega is equals to minus ap upon c bracket square plus minus bp upon c bracket square, and that's equals to 1. And therefore here you will get what you are getting here. This is the a square. I will write here a square p square upon c square, and the next term is a b square p square upon c square, and that's equals to 1. Again, one more thing is that take the p square as a common. Okay, p square as a common. Then in bracket you will get a square upon c square plus b square upon c square, and that's equals to 1. Okay, now transfer this, that is a here p square is equals to, as both of them have the same base, therefore we can write a square plus into here this is the p square, again p square into a square plus b square upon c square, bracket is completed, and this whole equals to 1, and therefore p square is equals to c square upon a square plus b square. Taking the square root on both sides, then you will get p is equals to plus or minus c upon in root of a square plus b square. This is the length of perpendicular drawn from origin on the line. Okay, now next, again cos of omega is equals to plus or minus a upon in root of a square plus b square, and the sine of omega is equals to plus or minus b upon in root of a square plus b square. Thus the normal form of the equation ax plus by plus c is equals to 0 is x cos of omega plus y sin omega is equals to p, and the cos of omega is equals to plus or minus a upon in root of a square plus b square. Sin of omega is equals to plus or minus b upon in root of a square plus b square, and p is equals to plus or minus c upon in root of a square plus b square. Okay, and the proper choice of sign is made so that p should be positive. Okay, now the example depending on this equation of line is 3x minus 4y plus 10 is equals to 0. Find its slope and the x-intercept and the y-intercept. Okay, the given equation is a 3x minus 4y plus 10 is equals to 0 can be written as in this form, which is the form y is equals to mx plus c. Okay, now here see this, here we have the equation 3x minus 4y plus 10 is equals to 0. Transfer this 4y to the right hand side, then you will get 3x plus 10 is equals to 4y, and divide on both sides by 4, and we can write it like this, 3 by 4 plus 10 by 4. Okay, and into x here y is equals to 3x by 4 plus 10 by 4 means what? It's a 5 by 2, and that's why here the equation y is equals to 3 by 4x plus 5 by 2. Okay, and from this we will have the slope of a line is compare with y is equals to mx plus c, slope is 3 by 4. Okay, and next the intercept, x-intercept and the y-intercept. To find out the x-intercept, y-intercept, convert this line, transfer this 10 to the right hand side, divide on both sides by 10, means see this here 3x minus 4y is equals to minus 10, divide on both sides by minus 10, and here you will get 3x upon minus 10, and again if you divide by minus, that minus and minus will become plus, 4y upon 10 is equals to 1, and therefore here we can write x upon minus 10 upon 3 plus y upon, we can simplify this, that is a 2 by 5. Okay, and it can be written as 5 upon 2 is equals to 1. Comparing this with x upon a plus y upon b is equals to 1, therefore a is equals to minus 10 by 3, and y-intercept is a b, which is the 5 by 2. Okay, now the next example, reduce the equation root 3x plus y minus 8 is equals to 0 into the normal form. Find the values of p and omega. Okay, now the given equation is a root 3x plus y minus 8 is equals to 0. Dividing by the on both sides by in root of root 3 square plus 1 square. Okay, root 3 square is a 3, 3 plus 1, 4, root of 4 is 2. Yes, okay. Now divide on both sides by this 2, then you will get, see this here, root 3, okay, root 3x root 3x plus y is equals to 8. If we divide by 2, then here you will get 8 upon 2, which is the 4. Means what? Root 3 upon 2x plus 1 upon 2y is equals to 4. Okay. Now, what is this? This is the root 3 by 2. And the cos 30 means root 3 by 2. And sin 30 is 1 upon 2. Therefore, we will convert in this form, cos 30 into x plus sin 30 into y, that's equals to 4. Okay. Now the value of comparing with x cos of omega plus y sin omega is equals to p. Here p is equals to 4 and omega is equals to 30. Okay. Now the example number 15. Find the angle between the lines y minus root 3x minus 5 is equals to 0 and root 3y minus x plus 6 is equals to 0. Now we have the line, equation of the line, y minus root 3x minus 5 is equals to 0, and another is we can write in this form, make this as a positive, then transfer this minus root 3x minus 5 to the right hand side, y is equals to root 3x plus 5. Second equation, root 3y minus x plus 6 is equals to 0. Again we can write root 3y minus x plus 6 to the right hand side, minus x will become plus 6 will become minus. Okay. Now see this here, root 3y is equals to x plus 6. Now divide on both sides by root 3. Then here you will get 1 upon root 3x plus 6 upon root 3. Now simplify this. Okay. When you transfer this minus x, it will become plus, and sorry, 6 will become minus. 6 become minus, again here minus sign, minus sign. And for this simplification, multiply this numerator and denominator by root 3. Then here you will get root 3 into root 3, that is a 3. 6 root 3 upon 3 means what? 2 root 3. This is the equation. Means the equation in y is equals to mx plus c form. Therefore, the slope of the second line is 1 by root 3 and first line is a root 3. We want to find the angle between the lines. That is a tan theta m1 is equals to root 3, m2 is equals to 1 by root 3. Tan theta is equals to m2 minus m1 upon 1 plus m1 into m2. Now putting the values of this m1 and m2 in this equation 3. Okay. Then you will get m2 is 1 by root 3. Okay. And m1 is root 3 upon 1 plus m1 into m2, root 3 into 1 by root 3. This get cancelled. Okay. And again the simplification. Here that is equals to, if you want to find out more simplification, 1 minus here root 3 into root 3 and this divided by root 3. Again multiply this with by root 3. Then here you will get root 3 plus root 3 upon root 3. Okay. And this root 3 get cancelled. And overall you will get 1 minus 3 and root 3 plus root 3, 2 root 3. Okay. 1 minus 3 means what? Minus 2. Minus 2 upon 2 root 3, 2 get cancelled. And it has a mod sign. Therefore, it will become 1 upon root 3. Therefore, tan theta is equals to 1 by root 3. And it indicates that, which gives the theta is equals to 30 degree. Because tan 30 is 1 by root 3. And hence, the angle between these two lines is 30, or the angle between these two lines 180 minus 30 also, that is 150 or 30 degrees. Now the next problem, show that two lines a1x plus b1y plus c1 is equals to 0, a2x plus b2y plus c2 is equals to 0, where b1 b2 is not are not equals to 0. Okay, if a1 upon b1 is equals to a2 upon b2, then the lines are parallel. Second, if a1 into a2 plus b1 into b2 is equals to 0, then the lines are perpendicular to each other. Now the first equation, that is a1x plus b1y. See this here, a1x plus b1y plus c1 is equals to 0. If we transfer this a1x and c to the right hand side and divide the whole equation by b1, then here you will get y is equals to minus a1 upon b1 into x minus c1 upon b1. This is the first one, and similarly the second one is also y is equals to minus a2 upon b2 into x minus c2 upon b2. This is second one. Okay, now what the condition we have, that is m1, the slope of first line, which is minus a1 upon b1, slope of the second line m2, it is a minus a2 upon b2 respectively. Now first, if the lines are parallel, now the both are equal, this minus and minus that will become plus, therefore a1 upon b1 is equals to a2 upon b2 when the lines are parallel. Okay, this is the first condition. Next, in second condition, the lines are perpendicular. m1 into m2 is equals to minus 1. a1 upon b1 into a2 upon b2, that's equals to minus 1. And the product of these two means what? a1 into a2 upon b1 into b2, that's equals to minus 1. And therefore, a1 into a2 is equals to minus, here, b1 into b2, and we transfer this to the left hand side, it will become a1 into a2 plus b1 into b2, that's equals to 0. Okay, this is the condition for the perpendicular. Two lines are the perpendicular. Now the next example, number 17. Find the equation of a line perpendicular to this line. Okay, and that line passes through 1 minus 2. Okay, now we have the line. Suppose that this is the given line. I draw the picture of this line. This is the given line. Its equation is x minus 2y plus 3. Okay, find the equation of a line perpendicular to this line, and that line passes through the point 1 minus 2. Okay, now there is one more line. Okay, it is perpendicular to this line. Okay, and that line passes through the point 1 minus 2. Now we know the slope of the line. Okay, and the minus and reciprocal of the slope is the slope of this required line. Okay, therefore the first line, see this here, x minus 3 is equals to 2y, divide on both sides by 2. Then here you will get 1 upon 2x. Okay, the line is x minus 2y plus sign. Okay, here is a plus sign, therefore divide on both sides by 2. Then here you will get y is equals to 1 upon 2x plus 3 by 2. Okay, the slope of the line is 1 upon 2. Therefore the slope of the line perpendicular to line, this line, is minus and reciprocal, which is the minus 2. Now equation of a line having the slope minus 2 and passing through the point 1 minus 2, use the slope point form, means y minus y1 is equals to m in bracket x minus x1. Substitute x1 y1 as 1 minus 2 and m minus 2. Y minus in bracket minus 2 is equals to minus 2 in bracket x minus 1. and evaluate it. Minus minus, that will become plus. Okay, y plus 2 is equals to minus 2x, and this is the plus 2. This 2 get cancelled, and here you will get y minus 2x, okay, which is the required line. Now the next topics, that is the distance of a point from a line. Okay, distance of a point from a line is the length of perpendicular drawn from the point to the line. Okay, if we take any line, okay, and this is the line, and if I take the point P here, okay, and I want to find out the distance of this point from this line, then that is nothing but the perpendicular distance of this point from this line. Okay, this is the PM, which is the perpendicular distance. That is nothing but the distance of a point from this line. Okay, let ax plus by plus c is equals to 0 be a line whose distance from the point P x1 y1 is d. Draw a perpendicular PM from the point P to this line, PM perpendicular to this line. If the line meets x-axis and y-axis at the point Q and R, then what are their respective coordinates? Suppose this is a line. When it meets the x-axis, its y coordinate will become 0. Therefore, ax is equals to minus c. Therefore, x is equals to minus c upon a. And this is the coordinate of a point when the line intersects the x-axis. Similarly, when this line touches the y-axis, put x is equals to 0. Therefore, y is equals to minus c upon b, and therefore 0 minus c upon b is the point where the line cuts the y-axis. Okay. Now we find the area of the triangle PQR. This is the PQR. Okay, and it is given by area of triangle PQR is equals to the PM, which is the height, and QR, that is the base. 1 upon 2 PM into QR, which gives, that is the PM is equals to, we required this distance, therefore PM is equals to, this 2 will be multiplied to this area of the triangle, that is a 2 into area of triangle. I will write here area of triangle PQR upon this QR. Therefore, PM is equals to 2 times area of triangle PQR upon QR. Next, area of triangle PQR is equals to, what is your formula? The formula is x1 in bracket y2 minus y3. Next, plus x2 in bracket y3 minus y1 plus x3 in bracket y1 minus y2, and in this way, this is the formula. Now the coordinates, about the coordinates, this is the x1 y1, and this coordinate is a x2 y2, and this is the x3 and y3. If we substitute, then you will get 1 upon 2 x1 in bracket 0 plus c upon b plus minus c upon a. Okay, this is the x2 minus c upon a, and in bracket y3 minus y1. There is a y3 is a minus c upon b, and y1. Okay, this is the, and last is a x3. What about the x3? x3 is a 0, y1 minus 0. This is a y1 minus 0, y1 minus y2, because y2 is a 0. Okay, and overall you will get here 1 upon 2 x1 into c upon b plus y1 into here, this whole bracket will be 0, and here minus minus, that will become plus, plus y1 c upon a, and the product of minus c upon a minus c upon a, that will become c square upon ab. Okay, again the evaluation, what is that? This 1 upon 2, this 2 is a transfer to the left hand side, that will become 2 times area of the triangle PQR. Next, take c as a common from this and multiply numerator and the denominator, this whole expression, by AB upon AB. Okay, AB upon. If we take from this expression as a C as a common, then what is that? 1 upon 2. This is the C, and multiplied numerator and the denominator by AB, and this is the bracket. What is that? X1 C upon B plus Y1 C upon A plus C square upon AB. Okay. Now the next is a evaluation. It is here 1 upon 2 C upon this AB. Okay. And next, multiplied this AB with all the terms. Okay. Then here you will get first x1 into 1 upon B into AB, as we have taken C as a common, therefore x1 into 1 upon B into AB plus y1 into 1 upon A AB plus, okay, and the last is 1 upon AB into, this is the one more C upon AB, and here is a AB. Okay, now this BB get cancelled, and that's why here you will get 1 upon 2 in mod of C upon AB in bracket x1A. Next, A get cancelled plus y1B. Lastly, this AB get cancelled and the term C will be remain there, and this is the plus C, and that's why the here then transfer these two to the right left hand side, then it will become 2 times area of triangle PQR is equals to C upon AB in bracket, okay, x1A or AX1 plus BY1 plus C. Okay. Next, find out the QR distance. That is by using the distance formula. Okay. The coordinate of the point Q is, here is a coordinate of the point Q, minus C upon A, minus C upon A 0 and R. Okay. Coordinate of the point R 0 minus C upon B, 0 minus C upon B. Okay. Now using the distance formula, 0 minus in bracket minus C upon A, that will become plus 0 plus C upon A bracket square plus. Next is a again 0 minus in bracket minus C upon B, that will become plus, and overall C upon A bracket square plus C upon B bracket square. Again here the QR is equals to, if we simplify it, this is the QR in root of, see this here, in root of C square upon A square plus C square upon B square. Okay. Now next the cross multiplication, take C square as a common. If you take the cross multiplication to the denominator, you will get A square B square. If you take its a square root, here you will get AB. And if you take the cross multiplication here, you will get A square plus B square, that is in root of here A square plus B square. See this again, once again, take the C square as a common, that will become C. Next, after the cross multiplication, B square A square upon A square B square, take A square B square outside this square root sign, it will become AB. It means that this C upon this AB. And in under root, here as you are multiplying with here 1 by B square, and here 1 by a square after drawing the c square as a common. Okay. And therefore, here you will get QR is equals to C upon AB in root of A square plus B square. This is the QR. Now, we'll substitute the value of area of triangle PQR and the QR in 1. See this here? Here, area of triangle PQR and the QR in this one, because we want to find out this PM. Okay. Therefore, the PM is equals to 2 times area of triangle PQR upon QR, and that's equals to, now 2 times area of triangle PQR means what? In mod of, here we will substitute the value 2 times area of triangle PQR and the value of this QR means what? I will write here equal to sign 2 times area of the triangle PQR means what? Mod of C upon AB. Okay. And in mod A x1 B y1 plus C. This is the first one. Okay. Next, upon QR. QR means what? Again, C upon mod of C upon AB. Okay. In root of A square plus B square. Now what's happening here? These two terms get cancelled, and therefore the PM, this PM distance, that is equals to AX1 plus BY1 plus C upon in root of A square plus B square, and hence the distance of that point P x1 y1 from the line Ax plus By plus C is equals to 0 is a in mod of Ax1 plus By1 plus C upon in root of coefficient of x1 square plus coefficient of y1 square, that is a square plus B square. Okay. And this is the final, okay, distance of a point from a line. You have to remember only the formula, okay, and not this big derivation. Okay, this formula is important one. Okay. Now the distance of two parallel lines. We know that the slope of two parallel lines are equal. Yes. Therefore, two parallel lines can be taken in this form. Y is equals to mx plus c1 and y is equals to mx plus c2. Both of them have the same slopes, but the different intercept of the y-axis. And suppose the distance between these two lines is small d. Now, when the first line touches the x-axis, if we substitute when it touches the x-axis, put y is equals to 0. If we substitute y is equals to 0, then here you will get x is equals to minus c1 upon m 0 as shown in the figure. Okay. Now the distance between the lines is equals to the length of perpendicular. Now we know this point, which is the minus c1 upon m0, and we can find out the distance of this point from this line, which is the y is equals to mx plus c2. Now see this here, y is equals to mx c2 mx c2. Now equation of this line can be written as mx minus y plus c2 is equals to 0, which is the point A, whose coordinate is a minus c1 upon m0. Now the distance of this point A from this line, replace this x by minus c1 upon m and y by 0. Therefore here that distance d is equals to, okay, this is the m. Replace this minus c1 by m minus c1 upon m, next minus y, okay, and overall that distance will become 0 plus c2, that is, here is a coordinate, y coordinate is 0, therefore it will become 0 plus c upon in root of coefficient of x square means what, m square, coefficient of y square means what, minus 1 square means 1. Okay, and if we simplify this, then here you will get, this is the C2. Okay, therefore minus m into minus C1 upon m. Okay, this will become 0 plus C2 upon in root of 1 plus m square, and this get cancelled, and here you will get minus minus, that will become plus C1 minus C2 upon in root of 1 plus m square. This is the distance between the two parallel lines. Thus the distance d between the two parallel lines y is equals to mx plus c1 when it is in this form, and y is equals to mx plus c2, then it is given by d is equals to mod of c1 minus c2 upon in root of 1 plus m square. And in general, if the lines are in this form, general form, ax plus by plus c1 and ax plus by plus c2 is equals to 0, then the distance is c1 mod of c1 minus c2 upon in root of a square plus b square. And this is the formula that you have to remember in the different form. Here the equation of the line in the form y is equals to mx plus c, and this is the general form, that is ax plus by plus c1. Okay. Now the problem, find the distance of the point 3 minus 5 from this line. Okay. And here the equation of the line in the form, which is the form ax plus by plus c is equals to 0. Okay. And the first line is a is a 3, b is minus 4, and c is a minus 26, and the point is a 3 minus 5. And here we apply the formula ax1 plus by1 plus c, that is the first 3 into 3, next minus 4 into minus 5, and the last is minus 26 upon in root of 3 square coefficient of that x and y, that is 3 square plus in bracket minus 4 bracket square. And if you simplify this, then here you will get 3 by 5. Okay, what is the simplification? 3 into 3, 9, plus minus 4 into minus 5, that will become 20, minus 26, and here to the denominator you will get a root of 25, and that is a 5. 29 minus 26, here you will get 3, which is the 3 by 5. Therefore the distance d is equals to 3 by 5. Okay. Now the example number 18. Find the distance between the parallel lines. 3x minus 4y plus 7 is equals to 0. 3x minus 4y plus 5 is equals to 0. Here first line, that is a is 3, second line a is also 3, b is minus 4, b is minus 4, but c1 and c2 are different. C1 is 7, c2 is 5. Okay, therefore we apply the formula d is equals to in mod of c1 minus c2 upon in root of a square plus b square. Here the form of the equation of line is a ax plus by plus c is equals to 0. Substitute the value c1 minus c2 in mod of 7 minus 5, that is 2, in root of 3 square plus minus 4 bracket square, you will get 5, which is the d is equals to 2 by 5. Okay. And in this way I had completed all the solved examples and basic theory for the exercise 10.3, and in my second video I will explain all the examples from the exercise 10.3, and I will give the link of this my second video in my first video. Okay, now we'll see in the next video. Till then, goodbye.